Hello and welcome to Weather and Its Surroundings. I'm Brian Ives. Today on Weather and Its Surroundings, we are going to be going in depth on the topics of global warming and climate change. While we have done a show on this topic before, I did want to go a little bit further in depth on the topic so our viewers had a better understanding of the current news of global warming and climate change. Joining me in the studio today to discuss these topics are two guests. Immediately here is Ali Shahin. Ali is a recent graduate of Mississippi State University. And you also may recognize him as he was the meteorologist on Newton News from back in 2003. We also have joining us today Michael Page. Michael Page is a meteorologist over at New England Cable News, right down the street from us here. And thank you both for joining me.
Thanks for having us.
It's good to be here. Thanks for having me.
Thank you. So before we go in depth into the topics, I feel like of global warming and climate change, I want to go into the both of you of specifically definitions so people understand what we're talking about, so we don't go all off on things and people have not an understanding. So we'll start with you. For my first question is, what is global warming?
Well, global warming, Brian, what in a nutshell, it's climate change, but going upward in temperature on a long-term basis. The consensus is that the increase in carbon dioxide emissions and other greenhouse gases, but primarily carbon dioxide, is causing temperatures on a global scale to increase. There has been a lot of debate on this topic, but the science is really moving towards an increase in temperature due to the production of carbon dioxide emissions due to anthropogenic factors. Now, when I say anthropogenic factors, I'm talking about us, we as the people, human beings, causing it, from driving of cars, motorcycles, the running of factories, the cutting down of trees, woodlands, because trees absorb carbon dioxide, and if you get rid of vegetation in all forms, you're pretty much adding carbon dioxide indirectly that way to the atmosphere as well. So that is pretty much a consensus that temperatures are increasing due to carbon dioxide production, and that's basically what global warming is. Now, in my view, that's the consensus. But in my view, if you were to ask me like what I think, I believe global warming is mostly natural with a small hint of an anthropogenic factor, but mostly natural because the planet Earth is warmed and cooled like millions of times in the past billions of years ever since its creation. So it's pretty much a natural cycle in my view, based on my research of the topic.
All right. So on the other side of global warming, we have climate change. Michael, can you tell us what climate change is?
Sure. Climate change overall, and as you just kind of alluded to, the world has always been changing. So it would just be encompassing all of those changes, whether it's a cold snap resulting in an ice age or one of these warmer periods that we're going through right now. So that would just be encompassing all of those changes as opposed to focusing on one change up or down respectively.
Okay. So then, can you tell us then what the difference between global warming and climate change is?
Well, like I said, I think global warming would just be segmenting out one of those changes as the climate changes overall. So again, we've gone through periods where the world has gone into an ice age. Meanwhile, right now, we're in a warmer phase. So a lot of people would refer to that warming as global warming. I tend to just use the term climate change overall because it encompasses all of that. I think that's kind of the more scientific way to approach it.
Okay. A lot of times people, when they think of global warming, and a lot of the terminology that comes in with that is greenhouse gases. How do greenhouse gases relate to global warming?
Now, well, that's a topic that can probably span 3 hours, probably a couple of days to talk about. But in a nutshell, greenhouse gases trap infrared long-wave radiation that's emitted from the Earth's surface, and traps it by absorbing it. Now, once it absorbs it re-emits it back to the Earth's surface, and some of it is re-emitted to space from that greenhouse gas layer in the atmosphere. But the net effect is to keep more of that greenhouse gas emissions of the greenhouse gases and temperature or infrared radiation just within the Earth's surface atmosphere model. So That is pretty much how, because if greenhouse gases didn't exist, what we would have is short-wave radiation, which is radiation coming from the sunlight,
Right.
aka sunlight, coming in, passing through the Earth's atmosphere, going through the ozone layer, being absorbed by the Earth's surface, turning into infrared long-wave radiation, and then just being radiated back to space without, just basically passing through the ozone layer. Now, if we have an ozone layer, that's okay, because infrared radiation is able to pass through the ozone layer back to outer space. But greenhouse gases, carbon dioxide, methane, trap, absorb greenhouse gas and re-emit it back to the Earth's surface. And that causes an increase in global temperature over the long term.
And of course, those aren't inherently
Right.
bad either. We need those to survive. So
Right.
we do
Right.
need some of that to some extent. The issue we're seeing now is that humans are emitting more than what would naturally occur,
Right.
at least in recent history. So we're trapping more warmth than we've seen lately, and that's why
Okay.
we're seeing the temperature increase.
All right, well, we're going to get into
Exactly.
temperature warmth in just a few minutes, but I also want to just continue on our quick little overview of definitions, specifically with the terms of El Nino, La Nina, and specifically that is El Nino. Specifically is something that we're hearing a lot more recently in media because researchers have said that this is one of the strongest El Ninos we've seen on record. I think back dating since the mid 1990s. Let's start off with what is El Nino and how does it develop into being such a strong El Nino to being what we're seeing as one of the strongest El Ninos on
Sure,
record?
this is one of those huge topics this year, and
Yeah.
I've certainly referenced it on air quite a bit because people are talking about it. And essentially what El Nino is a warming of the Pacific waters near the equator. So we see a rapid warming of those waters, very toasty, and that will then alter the jet stream pattern, not only across the world, but of course here in the United States. So basically that would bring a lot of moisture to California where they desperately need it. And it tends to leave us here in the Northeast warmer than average and typically doesn't favor a pattern that would be ripe for prolific snowmakers. Having said all that, there's a flip side to that, and that would be La Nina, and that would be a cooling of the Pacific waters near the equator. This is another one of those cycles. The world operates in cycles in many ways, and this is one of them. Warms up, gets cooler, you have ups and downs. Within that, of course, you're going to have very strong La Ninas and very strong El Ninos. As you said, this is the strongest we've seen since the late 1990s. 1998 was a big El Nino year. Going back to the early 80s, 82 and 83 was a big El Nino year. And those winters closely mirror what we're seeing to this point so far here in New England.
Alrighty then. So what I'm going to jump back, and we'll get back more into that El Nino and La Nina stuff in just a few minutes. But I want to get into now talking about that climate researchers have also announced. We're talking about record with temperatures here that the November 2015 was recorded as the warmest month on record. We actually have two images of this. Actually, not this one. The next image. We should see this one here. And this image specifically is the average from November 2015. And if we take a look at the one next to it, the next one, that is the what was set in November. What a tremendous difference. Am I correct in saying if you look at this image here, that the record warmth down in the southern part of the record warmest, is that in relation to this strong El Nino? Do those connect with one another?
They can. It can lead to some warming over land. Whether or not you can say El Nino is creating the record conditions, that might be a little bit of a leap, but it can certainly contribute to it. So there's actually been a lot of research about whether or not El Ninos are becoming more frequent in this warmer climate that we're currently living in. There's not a huge consensus on that, but there is a thought that maybe there will be more strong El Ninos, and in the United States, as we mentioned, that typically leads to warmer conditions. So you can sort of combine the fact that the climate is warming, that contributes somewhat. El Nino may contribute on a short-term scale somewhat. I don't know if you can say one way or the other, one completely results in the record, but they both have a hand, certainly.
There's so many factors in climate. And that's exactly as Michael said.
Right.
When we have, that's why people use the word climate change. Actually, I think as we move more forward in time, climate change is being used more often now than global warming, because people are seeing, well, yeah, we're having warmer weather, but we just had a freezing, snowy winter last year.
Right.
So, is there really global warming, or is it just climate change? It's not, the planet is warming, but is it really happening? Maybe just a natural thing, and temperature's going to start dropping again, like maybe in 10 years. So, and that is the same thing with the El Nino, La Nina, as Michael was referring to earlier, where it switches.
It's interesting to this topic of global warming, because I've interviewed on this show many meteorologists, and I've also interviewed experts that are specifically in the field of climate. You ask an expert in the field of climate if global warming is happening, they say they are more likely to say global warming is happening. You ask a meteorologist that same question, they're going to give you an opposite answer, saying, no, it's not really global warming. What do you, I mean, is this something that climatologists and meteorologists disagree on? Why do they not?
There is some pushback from on-air meteorologists, and I am one of those people who fully recognizes the research that the world is warming. There's really no question that we're going through one of these warm periods. There's also no question that we've gone through these in the past and that there have been cold periods as well. Having said all that, what's most interesting, and I think for most climatologists and researchers most concerning, is the rate at which we're seeing the warming happen this go around. It is much faster than the warm periods that we've seen prior to that, and that's where the human component comes in. So I tend to refer to this as human-influenced climate change because, of course, humans are playing a role in the rate at which it's happening. It's very hard to parse out the extent of that because there are so many natural factors involved. But again, you can't just say it's humans, you can't just say it's natural. There's obviously some blending, and as with everything else, it's trying to parse out how much is caused by which.
Okay. Well, going back to the image that we did see up here a few minutes ago that was supposed to come up around now, which was an image of global temperature trend. It was our first image back there, this one here. And I believe this goes back all the way, showing us records into 1998. And you can see what's interesting to look at with this, in my opinion at least, is that it looks like even really back from, the numbers, they go up and down, up and down. Is it more likely to see the trend of these average these year-to-date global temperatures being going up? Because as it says here, obviously for 2015 it was one of the warmest years on record. Is this a trend to expect to continue, or will we see temperatures cool down again and then warm back up and then?
Well, I think we may see this happen again. Like, I think temperatures will continue to go up. But again, like we were saying, as Michael was saying, there's so many factors involved, which makes it seem like there's an anthropogenic factor, but I think it's small. And it's a great thing to talk about. People have, there are different theories out there, but there's so many factors. Like one of the factors that I'm really concerned about is ocean warming due to underwater volcanic activity. And of course, when there's more underwater volcanism, there's above water volcanism, because volcanic activity is volcanic activity, whether it's above water or underwater. But that heats the oceans. That actually releases carbon dioxide into the air from the heated oceans. And that's actually a huge factor. Also, above water volcanic activity increases additional carbon dioxide into the air. So that definitely increases temperatures, but that carbon dioxide is coming from within the earth, not from automobiles or factories. So I think because of that, we got mostly natural global warming happening. But again, there may be an anthropogenic influence as well, albeit I think pretty small. So I do think that these temperatures will continue to increase, but in the long term, I'm inclined to think that they'll start going back down. After all, we did just have probably the snowiest winter on record. Some people could argue that's because of global warming. We got more moisture in the air, warmer temperatures, warmer oceans because of those warmer temperatures. So we got more moisture, more snow, but it also was very cold. So I don't know.
So a couple thoughts just based on that real quick. So volcanic activity, a great point of something that can kind of throw a wrench in these long-term trends. Sometimes when you have large explosions over land, it can actually lead to a brief cool down in global temperatures because of all the soot that's in the atmosphere.
Very good point.
In regard to this chart, I think you really have to remember that this is a very short time scale on the grand scheme of things. And oftentimes what we see with folks who don't necessarily acknowledge the warming of the world right now, they'll say, oh, look at the past couple of years here. You see a couple of these lines actually do go down, and they'll segment that part and say global cooling is actually happening.
Right.
And if you're using those 2 years, okay, you're right. The problem is that's not really a great sample size. So you
Right.
just always have to be very cognizant of what people are using when they're making their comments and make sure that, in fact, that does make sense. And the other thing I'll mention about the cold last year is it was cold.
Oh my God.
Right.
The Northeast.
Jesus
But
Christ.
when you look at one of those charts that you had before showing the whole globe,
Right.
Brian, it was just over us.
Right.
So you have to remember the
That's
global
also true.
scale of everything.
Right.
We were the little blue dot, and everyone else was under the red, and it was still a very warm year across the
Right.
globe. So again, perspective is critical when you're thinking about all of this and when you're looking at data in particular.
Okay. All right. Well, now what I really want to get into is I have a bunch of images that really, I guess you can either say show climate change / global warming. The first one here is of the shrinking Lyell Glacier at Yosemite National Park, and you can see the difference here between
nice.
1883 to
Nice photo.
recent 2015. Is this all in relation to the warming trend that we're seeing, and is this something? I mean, obviously we think this it harms our planet, but I mean, what is the real danger?
Now this is in the western U.S., right?
Yes, this is at
It's,
Yosemite National
Yosemite
Park,
National
yeah.
Park. Well, yeah, this is overland. So now this definitely would show that warming is happening. Because I mean, we got huge time span, 1883 2015. So that definitely tells you something. But then we have other reports coming in saying that the Antarctic glacier is increasing in size, and that's the South Pole, and even parts of the Arctic is increasing in size. I know it's not in mainstream news reports because also the media is controlled by the government in a way. So
Right.
and they're really
Well, I'll take issue with that because we're not controlled by the government. I get no paycheck from the government
Okay.
to choose my opinion. So
maybe not in that form, but yeah, right. No, yeah, no, but that's a good point. I'm glad you said that. But it's but the Antarctic area, the Arctic area, that counts for maybe 90% of glaciers on Earth, and there have been some reports indicated. Actually, I would like to point out a website, iceagenow.info,
Okay.
that has very good information and data to back what I'm saying up, because they actually have, they're saying they have a very nice chart of what it used to be, how warm the planet used to be, and actually the planet used to be so much warmer than it is currently. I think during the medieval period, and we didn't have automobiles and factories back then, but it was even warmer. So that is definitely something to think about.
And the world was definitely warmer at other periods, but again, I go back to the rate at which we saw the warming.
Right.
It's happening much faster now.
Right.
So with these pictures, as you said, it clearly shows warming in this period. Whether or not this has happened before and we just didn't have photographs of it, very well might have been.
Right.
And with regards to ice elsewhere, you have to remember that sea ice and land ice have different repercussions. So when you see sea ice expanding or melting for that matter, there's not going to be a huge fluctuation in the resultant sea level rise, which a lot of people is what they'll focus on.
Right.
But what is key, and that is growing around the South Pole, but again, that doesn't have a huge implication for sea level rise, and that's usually what people are trying to argue, one way or the other.
Right, because it's already out in the ocean, so we're not gonna
So, and even when you're losing it in the North Pole as well, that doesn't have a huge impact on the level of the water. But what does, and what's concerning about Antarctica in particular, is that the land ice is actually decreasing. So sea ice is increasing, but land ice is decreasing, and that is what contributes to sea level rise. So again, you have to make sure you're looking at land and sea and remember what you're considering. Now, of course, more sea ice will result in more, refraction
Albedo,
of the
albedo effect,
light.
Mhm.
But
right.
if you're talking about sea level rise, or if you're talking about temperature, it depends what type of ice you're looking at too.
Okay. Well, we're going to continue on with these photos. I feel like, because I'm going to look more at a glacier, which is a different type of. We're going to see the Calis Glacier in Peru. I don't know, and I believe this. I don't exactly remember the time frame on this picture, but for some, okay, yes, I don't think this was over as many years as the previous photo was, but it still. This one doesn't look as dramatically different. It looks different, but not as dramatic. And I'm gonna skip forward just so we can see the one more common that people look at, and that is the ice cap out in Iceland. And that one, well, it almost looks like there is no more ice there in that photo. you were talking about just a minute ago about the difference between glaciers melting over land versus obviously over bodies of water. What is there one that is more worrisome to look at, obviously, than?
Well, right. As Michael was saying, right. If we have more land, if we have land ice melting, it's going to, sea levels will rise if land ice is melting. But then I'm inclined to think also that if sea ice is, well, the thing about sea ice actually would be, I've heard, is decreasing, whereas land ice has been increasing. That's what I've heard, because again, due to the underwater volcanic activity, heating the ice above it. We got huge geothermal springs in that area, in the South Pole, North Pole, and elsewhere, actually, even across the Pacific Ocean. And so when sea ice melts, because of that, we got, well, if it was to melt, it would be because of the underwater volcanism, not because of carbon dioxide, maybe a little bit, but really because of the underwater volcanic activity just directly generating the heat up into the ice and melting it. But as that happens, the oceans are also warming, which would increase the moisture output into the atmosphere, and that would create more snows. Above water volcanic activity would create a layer of ash, which would help block the sunlight and help cool the atmosphere. That would also create more snows as temperatures drop, and that would help to actually increase the ice sheets over the land masses, including places like Iceland or thing. But this picture shows a different story.
Right. Now,
pictures are pictures. There are also other photos that show the ice has been increasing. And that's basically why we have a debate going on in global warming circles right now between scientists and scientists that are actually working for the government and doing, and they need to keep their paychecks. Keep their.
I guess I'm not as skeptical.
So,
I've worked with a lot of the researchers. I very much trust the research. I don't think there's any grand conspiracy here, and I think the concerning part when you look at these pictures over land, when you're losing ice, when you just remember the real-world impact of that, a lot of huge populations depend on the water that seasonally melts off of this. In the Himalayas, for example, that's feeding major rivers in India where we have billions of people. So you just have to remember the human impact of all of this in our lifetime is that it's creating real problems, and you need to figure out how to fix that. Whatever the cause may be. People need water to live.
That's right.
So we're going to continue on with, we have a couple more photos. The next one here is appears to be is the Northwestern Glacier here in Alaska.
I love these photos, by the way.
This is from NASA Climate Change. They have anyone looking for them, they have a great app for the iPhone and a lot of great photos on their website. That's how I found those, so credit to them. This is out in Alaska, and it's incredible looking at this photograph, seeing, okay, you had the ice, and there was definitely ice there, to now it just looks like a body of water now. It just, I mean, obviously the more rapidly it seems to be over time that we see the temperature rapidly increase, that's what is obviously results to ice melting. But we talk about a lot of the big thing that people think to combine with that is the rise in sea level and the impact that will end up having. With the rate at the temperatures speeding up, what is obvious? I mean, we look at that, and what is the obviously worrisome on how bad the rise in sea level could get?
I just did a story on this during the Paris conference.
Right.
I spoke to the commissioner of Boston's Environment Department, who was in Paris for the meetings. So right now, the world has warmed 1 degree Celsius from pre-industrial times, potentially on its way to about 2 degrees Celsius. That's where hopefully this Paris conference that's the goal, to end the warming at 2 degrees Celsius. If the world were to be as warm as that, last time it was that warm, sea levels were some 15 feet higher than what we have right now. 15 feet higher would basically put most of the city of Boston and parts of surrounding areas underwater. That wouldn't happen for hundreds of years. I mean, that takes a lot of time. But, of course, when you think of the population that's near the water, if you have that type of increase, you'll have a lot of people displaced.
All right. So the next photo we have is showing more, I guess, of an opposite approach. It shows a shrinking lake out in in Argentina. This is out in Argentina, and it is considerably shrunken compared from before to now, which I feel like we're talking more of an opposite approach. But I think obviously, I think maybe I'm wrong here, has to do more with climate. You look at what's been going on out west in the country, out west with all the wildfires out there because of the dry conditions. But now, well, with El Nino, they're getting all that record rain. I mean, what? I mean, is this something to expect to see more with rapid temperature change, or is it more likely to see the ice caps melting, creating rise in sea level? Is there one that's more likely than the other?
Well, if you're living at the coast, you have to be worried about rising sea level. This is overland. This is a lake. We're not talking about an ocean here, or we're talking about ice melting into the sea around here in Argentina. So here, I mean, as temperatures warm, we have drier conditions. We got more. It would be much more difficult to saturate the air for it to rain, or have any kind of precipitation for that matter. So yeah, you would most likely have shrinking. You have more evaporation rather than precipitation and condensation coming in. And so
just remember, you have to again think about, are you talking about one specific spot or the whole world? Because it will vary depending on where you are. While some areas may face more drying in the future, you have to think about land use. Are people extracting more water now? How are people impacting that? Plus, here in the Northeast, we're actually seeing an increase in heavy precipitation events. So will we see fuller reservoirs?
Right.
It's kind of a hard thing to generalize.
Okay. Well, I know that this photo that we're about to see, we're going to skip one photo forward and go to the photo of the snow here in Boston from last winter, which none of us want to see that. I know. None of us want to think back to that last February. And it almost seems like we're now, what is this? We're taping on January 11th. And it almost seems like we were seeing the same type of pattern setup that we saw exactly last year. What would be the chances of, and let's not say that would happen, of seeing something like that type of repeat from last year?
Very slim. I mean, first of all, last year's snow is 112 inches. I mean, any winter, it'll be very difficult to have any winter copy that kind of performance that the atmosphere gave us last year. But also, we have a strong El Nino, and that does mean more moisture, more active storm track, but it also means a warmer regime for the winter. So so we'll have more in the way of rainstorms or a rain-snow mix rather than a complete powdery snowstorm regime this winter, which is what we had last year. But this winter, for those reasons, I don't see this happening.
Alrighty. So we just have a couple of minutes left. What I also want to just quickly talk about is that besides from the snow that we saw in Boston, we have also had, really over in the summer, we had, it seems like a spike in the past few years of tornadoes, a lot more severe weather that up here that we don't normally see. Is this something that's either relation to global warming, or what would cause it? Why?
There's really no proven research to say that any one aspect of severe weather will increase with a warmer world. There has been some discussion as to whether or not we're seeing more tornadoes lately, for example. Hard to say because people are also observing it more carefully. We have a lot more cell phones and people spread out all over the place.
Alrighty. Well, with that being said, what an amazing show we had today, but we are already unfortunately all out of time. I want to thank my two guests here, Shahin and Michael Page, for both joining me today.
It's good to be here.
Thank you again. I also want to thank everyone who helped out behind the scenes today. Thank you to Eugene Fogelman and UTV.